Hi folks, this is number 20 from page 158, and we have a situation where 120 MP3 players are currently being sold at $100 each, and every time you increase the price by $2 you sell one less unit, and they tell us that the cost to produce every unit is $70, and they want us to find a way to maximize profit. Okay, so let's start off here, and I'm going to let X be the number of MP3 players. Okay, so I'll just say number of units. Okay, and I'll start with the easier one. I think the cost is the easier one. So the cost with respect to the number of units, it's just $70 each, so it's just going to be 70X. Okay, we want to find the revenue, and the revenue is given by the number of units sold times the price for every unit. So this is what we have to actually calculate, is the price. Okay, and since it's a linear function, I can just work with 2 points. So I know that if I sell 120, the price is going to be $100. Okay, and if I increase the price by $2, the number sold will go down by 1. So if I sell 119, that's when the price is going to be 102. Okay, and so now let's start by finding the slope. So here we have 0 minus 2 is negative 2, or 100 minus 102 is negative 2, over 120 minus 119 is just 1. So there's my slope, and let's stick this into y equals mx plus b. So I'll use the first point. So y is 100, negative 2 times x is 120 plus b. So b is just going to be equal to 100 plus 240, so 340. Okay, so that means p of x is equal to negative 2x plus 340. Okay, so now we can put this all into the cost equation, the profit, which is what we're trying to maximize. So p of x we know is the revenue minus cost. So the revenue is just x times p at x, so negative 2x plus 340, and then minus the cost, which we said was just 70x. Okay, so let's simplify this here. So we got negative 2x squared. Okay, and here we've got 340x minus 70. So that'll be plus 270, I guess, x. Okay, so here's my profit function, which I notice is a quadratic with a negative leading coefficient. So I know I'm guaranteed to get an absolute maximum. So as long as you know, that x value that gives me the absolute maximum is not a negative number, I'm good. Okay, so take the derivative, and we get negative 4x plus 270. Need to make that equal to 0. So x, let's just solve that, is just 270 over 4. So 270 divided by 4 is equal to 67.5. Okay. So obviously we can't work with 67.5 because we're number of units, so we've got either 67 or 68. Now the reason why it could be either one is, remember, this is just a quadratic. So if this represents the axis of symmetry, we know should be the same profit whether I sell 67 or 68. Okay, so let's go back to the question, and I look and I see that what they're actually asking me for is what price should the store sell the MP3 players for. Okay, so I just need to input each of these into the price function, and then I guess I could have two answers. But the way I look at it is, presumably if you're going to make the same profit, you might as well charge as little as possible, get more people in the door, perhaps. So here, since the price function is a decreasing function, I know that 68 is going to give me the lower price between the two. Okay, so for my answer, that's what I'm going to use. So I'm going to calculate p at 68, which is negative 2 times 68 plus 340 is 204. Okay, and there we go. This is the price that we should charge to maximize the profit. Had you also given me the price using 67, that would have also been acceptable. Presumably you would have gotten, though, a larger number. Okay, so just a quick recap here. So I solve these problems by letting the variable always be the number of units involved. So it's just a matter of finding a function for the cost, which was pretty straightforward, and for the revenue, it really is about determining a function for the price function, since the revenue is just x times that price function, and we were able to do that easily because it's a linear function. Okay, that's it for this one.